Pythagoras' theorem can be visualized using areas. In any right angle triangle, if we draw squares emerging from the three sides, we'll find out that the sum of the smaller squares equals the big square. In other words, if we add the blue and the orange areas, we will obtain the green area. 3 squared plus 4 squared equals 5 squared. There are many ways to prove Pythagoras' theorem. Perhaps my favorite is this one. Let's take our right angle triangle with sides A, B, and C and rotate it 22 degrees, 35 degrees, until we reach 90 degrees. Repeat twice until we have a perfect square. In fact, we have now 2 perfect squares. The outside square with sides length A plus B, the inside square with sides length C. We also have 4 right angle triangles, base B and height A. The big square equals the sum of the small square plus the 4 triangles. This leads to the equation a squared plus 2ab plus b squared equals c squared plus 4 times a half of ab or 2ab. Cancelling 2ab out from each side of the equation, and voila, Pythagoras' theorem. Stop the video here and find the lengths x and y. Right, did you try? The length x is the hypotenuse of a right angle triangle, so adding the squares and taking the square root leads to 18. The length y is a short leg, so minusing the squares and taking the square root leads to 7.94. Let's see an application of Pythagoras' theorem. A ladder has legs 10 meters long. The legs are 1.5 meters apart at the base. How tall does the ladder reach? We use Pythagoras with hypotenuse 10 and short side 0.75. That's right, Pythagoras only works in right angle triangles. The ladder reaches 9.97 meters high. Another interesting application. Is this a right angle triangle? Well, we know that 3 squared plus 4 squared equals 5 squared, so Pythagoras works. The triangle is a right angle one. Want more practice? Access full courses, quizzes, and worksheets in the link below. Happy learning!